Hey everyone, my name is Gary, part of Group 12, and today I'm going to be going over the following combined structural problem using an IR spectrum, carbon 13, and a 1H NMR chart. So, with this molecular formula, we're going to create the proposed structure. Now, before creating the structure, we need to find a degree of unsaturation. So in order to do that, we'll be using this molecular formula. So I'm going to write that down. C10H12O, and we're going to use the following formula. So degree of saturation 2C plus 2 plus N minus H minus whatever atom. So the 2C, which is a carbon, plus 2 plus nitrogen minus hydrogen and minus whatever extra molecule or extra atom that would be in. So after plugging in all of those numbers, we'll get the degree of saturation of 5. So this degree of unsaturation represents an aromatic ring, which includes 3 bonds in one ring and 1 CO bond outside of the ring. So now, going to our IR chart, so let's label this IR chart, and looking at these following peaks across the length, we'll start with this one here, and it is a CO bond. And with the CO bond, that means that we can either have a ketone or an ester. Looking at the next chart, we'll be able to determine which one that is. So now looking at these two peaks here, there's a C stretch, and this bond tells us that we have a benzene ring. But in this case, I'm going to refer to it as an aromatic ring. And then this one here is a CH bend. And at this peak here, we have another CH bend. So now the carbon 13 chart, we need to find out if it's a carbon or an ester. So a way you can find that out is between 165 to 175 ppm. That's where it's gonna lie. So anything greater than 200, we know it's a ketone. So between these between 120 and 140, there's going to be a CC bond. Between 30 and 40, there's going to be an aromatic carbon. And a CC aliphatic bond at the 20. Next is the NMR chart. And it's going to help us put everything together. So starting at the integration or the chemical shift of 7 and 8, we have 3H plus 2H, which we would consider to be a multiplat because you can see how many peaks there are. So now if you put both together, that would mean that we have 5 aromatic unsubstituted benzoate. Ring. Now, if you look at the chemical shift between 3 and 4, you have the 1H integration, which, as you can see by the tips, it's a multiplat. And 1 and 1.5 chemical shift, we have the 6H integration, which is going to give us a doublet. And at the doublet, we can interpret that there's going to be a bond that looks like this, CH, CH3 with the CH3 bonded to the 2. So everything in the graph, we're going to write down based off the charts. So give me 1 second while I fill this out. So for the IR, between 16 and 17, we saw C bonded. Between the 1585 and the 1600 and the 14 to 1500, we saw the CC stretch. And we said that was aromatic. With the 1000 to 1200 and then the 7 to 800, we saw the CH bond. I'm sorry, not bond, the bending, CH bending. And that too is aromatic. Next we do the 13C, or the 13 carbon. All right, we said the 200. I'm just going to split these up a little bit. 120 to 140. And then the 30 to 40, followed by the 20. Now we'll start from the bottom here. On the 20, we said it was a CC bond, and that was adiabatic. And then with the 30, that was an aromatic carbon. And then from 120 to 140, there was a C double bond aromatic. And then lastly, carbon bonded, double bonded to the oxygen. Then lastly was the NMR chart, or the 1 hydrogen chart. And 1 to 1.5, 3 to 4, 7 to 8. Integration would be the 6H. I think it was a 6H, 1H, and 2 and 3. Okay, so 3 or 4, that was a 1H. And then the 2H plus 3H, like we discussed. And then we said that that was a doublet. This here was a multiplet because of all the additional waves there, or peaks. And we also said that this was the same thing. Right? Excuse me. Hands getting tired. And then for this one, we said CH bonded to 2CH3 with 6. And we said it was unsubstituted. And this one was a CH bonded to a CH3. Okay, that's what it was. So CH3 bonded to a hydrogen of 6. And we're going to take this one off. With 6 protons. And then this one was the CH3, the helium, or not helium, the hydrogen of methyl groups. Now, once we put everything together, we're going to get this structure. So let's draw the benzene ring. And then we will connect that to a C bond. We're going to connect that to an oxygen. And then we're going to connect the carbon connected to 2 CH3 bonds. Right? And a chemical name. It's going to be isobutanol. So that's it. Thank you.